This demo will show you how to use the statistics calculator to get inverse normal distribution solutions. So again, you'll go to the distributions and normal. So everything for normal distributions you can handle right here. Now, for the normal distributions to do an inverse, we're not calculating the area, that's a probability. We're calculating an x value. So select that. And notice it automatically switches you to a left tail probability. And that's because it is just being consistent with the way the calculator works there. But you can actually do a right tail probability. I just haven't enabled that yet. And that can be very convenient. Anyhow, we can answer these kinds of questions. Let's see. So a particular fruit's weights are normally distributed with a mean of 257 grams and a standard deviation of 12 grams. So we have a mean of 257 grams and a standard deviation of 12 grams. So let's enter those values and press update, and it will adjust the scale on the axis. All right, you don't really see the normal distribution curve itself changing. It readjusts some other scales to make it look the same, but in general, that's all you need to do. Okay. Now we're trying to figure out the heaviest 17% of fruits weigh more than how many grams. All right, so the heaviest 17% of fruits. So the thing is, if you'll notice down here, you can see the percentages changing. And what we're looking for is the percentage, which is the area under the curve, to reach 17%. And you can't really get exactly on that very easily, which is why this is an input box and you can just enter that directly. And when you hit calculate, it knows to come up with a new value for x such that it is corresponding. Now, notice that we get 245.84. It doesn't really make sense with the context of the problem because this said the heaviest 17% of fruits. So in order to this is less than the mean, so these would be the lightest 17%. So that's where this thing of the making sure you're always doing an area to the left when you put in the input value. So if you have the heaviest 17%, then that's an area to the right. The corresponding area to the left would be 1 minus 0.17, which you do have to compute. It won't calculate that for you. That would be 0.83. So let's hit calculate there, and it comes up with 268.45 in this case. And it did say to give your answer to the nearest gram. And that makes more sense with the situation because this is a boundary. In white here is the heaviest 17%. In blue is the lightest 83%. So all we need is this value right here. So we can use either input probability. We can use 17% if we were able to use an area to the right, or we can get the lower 83% for the area to the left, which is how we have to handle that. So 268 is the answer to that question.